All right, in this video, we want to do the curve sketching algorithm for this rational function over here. Now, the good thing about this function here is that it's already factored for us, so we don't have to factor anything, which makes things a bit easier in this question. So the first thing I want to do is I want to see if I can simplify this equation and I can cancel out an x on the top and the bottom. So I'll have 2x minus 5, x plus 2 squared over x minus 4 squared times x plus 5. Now canceling out these x's is going to create a whole, and the x value of the whole is the solution to the factor that I canceled, which is 0. To find the y value of the whole, I can sub in 0 into this whole equation over here. So I'll do that in my calculator. And I get negative 1 over 2 as the y value of the whole. So now looking at this simplified equation, I want to state my vertical asymptotes. Next, my vertical asymptotes are the solution to the denominator, which is x equals to 4 and x equals to negative 5. I'll do my horizontal asymptote next. So if I look at the degree on the top over here, my degree is 3. To find your degree and your coefficient, you just take all your terms, including the front and the biggest terms of each bracket, and multiply it by each other. So 2 times 2x is 4x, and 4x times x squared is 4x cubed. So this is the largest term, the coefficient and the degree of the largest term on the top. For the bottom, it's x squared times x, which is just x cubed. So I can tell that the degree on the top and the bottom are the same, which means I have to divide coefficients. So 4 divided by 1 means my horizontal asymptote is y equals to 4. Next, I'll do my x-intercepts and my y-intercepts. My x-intercepts are just the solutions to the numerator. So for this bracket, it's just 5 over 2. And then for this one, it's negative 2. But also keep in mind that this bracket is squared. And if any of your x-intercepts have a square on the bracket, it means that it's going to be a degree 2 intercept over here. So just keep that in mind. For my y-intercept, you want to sub in y as 0 into this equation, but the whole had an x value of 0, which means there's no y-intercept because the whole actually takes over that point. Now that I have all this information, I can start my sketch. The first thing I want to do is I want to put my vertical asymptotes. So x equals to 4. And x equals negative 5. Next, I want to do my horizontal asymptote, which is y equals to 4. But I don't want to go all the way through because this is a very complex graph. I just want to put my horizontal asymptote at the ends of the function. So y equals 4 is my horizontal asymptote. Then I'll put all my points. So I have a whole at 0 and negative 1/2. I have x-intercepts at 5 over 2, which is approximately over here, and negative 2, which is over here. And now I want to start my sketch of my function. So the first thing I want to do is I want to take a really, really low value and sub it into this function. So I want to do f of, I'll pick negative 100, but you can pick any really small negative number so that we get the end behavior towards the left. I'm going to sub that into this equation. I'm going to see what I get. So if I sub that into my calculator, I get, oh wait, I made a mistake here. I accidentally miswrote one of the hundreds, negative hundreds as a 10. So I get 0.99 approximately if I sub this in. I'm going to try this calculation again because I feel like might have made a mistake because, oh no, here we go, I found it. I get 3.83. So your value should be really close to your horizontal asymptote. That's how you can tell if you have a typo in your calculator or not, because the value should be either slightly below 4 or slightly above 4 for the end behaviors. So now that I got 3.83, I know that my calculation is correct. 3.83 is slightly below this line. Next, I'm going to sub in a value for my vertical asymptote that's slightly less than -5. So I'll put a -5.1 in this equation. I want to pick something really close for the vertical asymptotes. I get 35.27. I know that's a large positive number, which means that it's going to be on the top over here. So now, how do I draw this connecting to this if there's a horizontal asymptote over here? Well, we can't just go straight through the asymptote. We have to hug the asymptote for a bit. You got to turn back, and then there's going to be a minimum somewhere over here. And then it's going to turn back and go up towards the top like this. That's the only way it's possible to have two connections over like a horizontal asymptote like that. You don't need to find this minimum point because that's going to be done in calculus. So now we have the left side of the graph. Next, I want to do the middle part of the graph. So I want to find something slightly higher than -5. So I'll do f of -4.9. And if I put this in my calculator, I'll get -31.4, which I know is a really, really small number. This graph is going to start on the bottom. So I know this is going to connect to this point. Now remember, this x-intercept of -2 was a degree of 2, which means my graph is not going to go through this. It's going to just rebound off this because it's got to be square over there. It's going to pass through the hole over here, going to pass through this point. This is a regular x-intercept, which means I have to go through. And now my only option is to go up. So I don't need to really calculate the end behavior on this side because now it's kind of obvious based on the shape of the graph. Normally you would do f of 3.9 to figure it out, but this is kind of obvious to figure out. So I know my solution is up over there. I can label my points now -2, -0.5, and 5/2. And last, I want to do this side of the graph. So I need to find my end behavior here. So I'll do f of +4.1 to figure out that end behavior. And I get a really large value, 2,400 and something. So since it's a large positive value, it means it's all the way at the top. And then the last thing I need to do is figure out my end behavior towards the right. So for that calculation, I'll do f of positive 100. Last calculation here required for my graph. And I get 4.19. 4.19 is slightly above 4, so I know it's above the line here, which means these two just connect over here. So it's just going to be like this. And that is the final graph of this rational function over here.